because now this upright side is the adjacent side. Okay? Tangent of theta will be what?
51/7.
Yeah, that's opposite. I had to check since I put theta in that spot. Square root of 51/7 be a little bit more than 1 in this case. Cosecant of theta is 10/√51. You guys got the pattern?
10/7.
Yeah, secant of theta is going to be 10/7, greater than 1.
And
7/√51. Carrie, you're good at this. Okay, any questions on this one, including the part where we found the third side? Nope. Okay, we're going to do one application problem, and I'm going to steal it from the book because if I make up the number, it'll be terrible. All right.
I bet you made up a terrible number and we laughed at you.
No, so I'd like to finish this before class is done.
We have a while.
Thanks.
Okay, it's got like 15 minutes.
Well, you can be entertained by my efforts to draw a regular polygon. Okay? Now, you should have done this in geometry, but it might have been a while.
Does draw stop?
And I remember for some of these,
Eesh. That's really bad.
that's really bad. I should not.
That's a really bad hexagon. I'm sorry.
I should not design.
It's not heinous. I mean,
It's not regular,
it would
though.
be better.
No, it's the bottom one that need to be longer. That's better.
That's as good as that's getting. Okay, now, if all I tell you is that it's a regular hexagon, if all I tell you it's a regular hexagon and one side is 8, can you find the area?
Yeah.
Yeah.
It's a very small amount of information there.
Wouldn't they all be equal?
Oh, what would be equal?
All the sides?
Oh, the sides. Yeah, so all the sides are 8. Okay? Now, how do you find an area of this thing? What shape can you break this down into?
4 triangles.
Triangles. How many triangles?
4.
More now. It's going to be one triangle for each side. So I can make it into 6 triangles. Now, everything I just mentioned only works for right triangles, all the sine, cosine stuff. I can make them all into right triangles. I drop a line down here, and I've got a bunch of right triangles.
12.
Yeah.
I've got 12 right triangles now. What's this length of this side here?
4.
4. Now, the
That would be,
well, now, how many degrees goes all the way around a circle?
360.
360. Okay, if I've got 12 of these triangles, since this is a regular polygon, they'll all be the same size. I'm taking a lot for granted here. So what is 360 divided by 12?
30.
30. So each one of these is going to be 30 degrees.
So the other one's going to be 90. I mean,
So
60.
I have 12, the other one will be 60, that's right. I have 12 identical triangles, which all look something like 30 degrees, 60 degrees, and this side is 4. Why? All right, why are we doing this? Okay, has anyone got a calculator handy? You can tell me the sine of 30 degrees. Make sure your calculator is in what's called degree mode. If you're not sure, hit mode and make sure the word degree is blinking. 0.5. If you hit sine of 30 is 0.5. Now the sine of 30 degrees is 0.5 or 1/2. How does that help me at all? It doesn't? Can't think of a single way that helps me?
Oh,
Besides, what about it? Well, sine 30, bless you, is a ratio of opposite over hypotenuse, right?
yeah.
Okay, and if it's 30 degrees, that ratio is 1/2. That means the hypotenuse is twice as big as the opposite side. So for this to be a ratio of 1:2, what does the hypotenuse have to be? 8. See, if you know that opposite over hypotenuse, it has to equal both 1/2, and then in this triangle, which is proportionate, you set up a proportion so it's 4 over the hypotenuse in this case. Can you solve this for the length of the hypotenuse, even if the numbers are uglier?
No. 8.
8, yeah, it's going to be twice as big. If the numbers weren't that simple, you could cross multiply. Hypotenuse times 1 equals 2 times 4.
It'd be 8, 8, 4.
So this is going to be 8. We don't know about the other side yet. What we know now is that this length is also 8. What's the area of a triangle? What's the formula for it?
1/2 base times height.
Right, area of a triangle is 1/2 base
It wasn't the AC2.
times height.
Oh, that's what
Okay? I've got the base of this triangle. Do I have its height? No. There's 2 ways from here I can find its height. Now that since I know its hypotenuse. I could use the cosine of 30 degrees. I could use the sine of 60 degrees and set up a ratio, because see, 60 degrees is opposite this side. Or I could just use the Pythagorean theorem since I found the hypotenuse.
What if the other side is 12?
Well, it can't be bigger than the hypotenuse. So it's got to be between 4 and 8. And it's going to be an ugly decimal of some kind. In fact, if we use the Pythagorean theorem now, we get a squared plus b squared equals c squared. Gives me 4 squared plus b squared equals 8 squared. What's 4 squared? 16. So 16 plus b squared equals 64. So b squared equals, what's 64 minus 16?
48.
48. So b is going to equal the square root of 48. Let's leave this in radical form for now. Are there any square roots in 48?
It'd be 6.9.
Okay, I don't want it without a calculator right now. I'm still in without a calculator.
4.
Okay, 48 breaks down to 4 times what?
12.
4 times 12. Does 12 break down further?
Yeah.
2 and 6. 3 and 4.
3 times 4.
I like
Which is
3
2 and
times
2.
4 because then I get 4 times 4 times 3. And what happens when I... 4 root 3. If a factor occurs twice, it can escape. So now I know that this adjacent side is 4 root 3. I could have found that by the cosine, using the cosine as well. Okay, so now I know how tall it is. So now, did you guys get to this in geometry? Did you do area of regular polygons this way? Does this look at all familiar?
Kinda, yes.
Maybe. All right. This is often on standardized tests. They'll give you this. They might give you some sine and cosine help. I'm not sure anymore. Okay, so now here's what I know. The area of this hexagon, this regular hexagon, is going to equal 12 times the area.
12.
Well, there's 12 of these little triangles in here.
Oh,
Okay? So it's going to be 12 times the area of a triangle that's 1/2 a base of 4 times a height of 4 square root of 3. So what's 12 times 1/2? 6. So this is 6 times 4 times 4 root 3. What's 6 times 4?
24.
24. Thank you. 24 times 4 root 3. What's 24 times 4? 96. 25 times 5 times 4 minus 4. All right, so that's going to be 96 square root of 3 units squared. Square units is going to be the area of that hexagon. We only needed to use the sine once to get this length to use the Pythagorean theorem. We could have used the sine or the cosine, but we needed trig in order to do it. Okay?
Oh, 96 would square.
Yeah, square units as a shorthand. So you could do any of that I've done so far without a calculator. Some of your homework will require a calculator, some won't. Don't use the calculator when you shouldn't, because I'll be expecting to see an answer of square root of 3.